Right now, something from another star system is hiding behind our Sunday. And when it comes back out in December, we might finally know if we're alone in the universe. Or worse, if we've been watched this whole time. On July 1st, 2025, astronomers in Chile spotted a dot moving through space. Just another comet, they thought. But within days, the measurements started coming back wrong. The chemistry was impossible. The trajectory made no sense. And then the photos from Mars showed something that made NASA go completely silent. This is the story of 3I divided by Atlas, the third interstellar object ever detected entering our solar system. And it's the story of how 7 impossible anomalies, 1 suspicious government blackout, and a single photograph have created the biggest controversy in modern astronomy. Here's what you need to understand right from the start. We've only ever confirmed 3 objects from interstellar space entering our solar system. 3 in all of human history. The first one was called Oumuamua. It showed up in 2017, looked weird, and left before we could study it properly. Scientists argued about it for years. Some said it was just a strange rock. Others, including a Harvard professor named Avi Loeb, suggested it might be artificial. That debate never really ended. The second one was Borisov in 2019. That one was boring. It was just a comet. Ice and rock, exactly what you'd expect. It didn't do anything strange. Scientists were almost relieved. But now we have number 3. 3I divided by Atlas, and this one is different. This one is so weird that space agencies around the world simultaneously stopped talking about it. This one is so strange that its chemical composition violates basic rules of how matter forms in the universe. This one followed a path so precise that the statistical probability of it happening naturally is basically 0. And here's the thing that keeps me up at night. Every single time we get new data about this object, every time a new telescope looks at it, every time someone runs the numbers again, it doesn't get less weird. It gets more weird. The worst theory about what this thing might be keeps getting stronger with each new image. And that theory is something most scientists don't even want to say out loud. Let me walk you through exactly what's happening, because by the end of this, you're going to understand why some very serious people are quietly freaking out. Part 1. The Discovery. July 1st, 2025. The Atlas Survey telescope in Chile is doing what it does every night, scanning the sky for anything that moves. It's an automated system funded by NASA, designed to catch asteroids that might threaten Earth. The telescope takes pictures, the computer compares them, and if something moved between frames, it flags it for review. On this particular night, the system flagged something at 4.5 astronomical units from the Sunday. That's about 420 million miles out, roughly between Mars and Jupiter. Just a faint dot. Magnitude 19, which is incredibly dim. You'd need a decent telescope just to see it at all. The first calculations came back within hours, and immediately, astronomers knew this wasn't a normal object. The orbit was hyperbolic. Not elliptical like everything born in our solar system, but hyperbolic. That's the mathematical shape that describes something passing through, not orbiting. Something that came from somewhere else and is just visiting. They called it C/2025 M1. The C meant comet. The rest was just catalog numbering. Within 48 hours, enough observatories had looked at it to confirm the hyperbolic orbit beyond any doubt. And that's when it got its official designation as the third interstellar object, 3I/Atlas. Now, finding an interstellar object is already incredibly rare. Space is huge, unimaginably huge. The distances between stars are so vast that even if another star system is constantly ejecting rocks and ice balls into interstellar space, the odds of one of them actually hitting our solar system are tiny. Think about it like this. Imagine you're standing in the middle of the Sahara Desert. Someone on the other side of the desert throws a grain of sand in a random direction. What are the odds that grain of sand hits you? That's basically the scale we're talking about. So just detecting 3, I divided by Atlas at all was special. But that's where the normal part of the story ends. Because when astronomers started actually studying this thing, nothing made sense. Part 2, the size problem. The first major problem was the size. When you spot something in space, you can measure how bright it is. And if you know how far away it is, you can work backward to estimate how big it must be to produce that amount of light. It's not perfect, because you have to make assumptions about what the surface is like, but it gives you a ballpark number. For 3, I divided by Atlas. Those calculations kept coming back with numbers that seemed wrong. Initial estimates put it somewhere between 5 and 20 kilometers in diameter. Let me put that in perspective for you. Oumuamua, the first interstellar object, was about 200 meters across, less than a quarter kilometer. Borisov was roughly 1 kilometer across. 3, I divided by Atlas, is potentially 20 times bigger than Borisov. And compared to Oumuamua, it's not even close. We're talking about something that could be 100 times more massive. This is a Manhattan-sized object from another star system. Now, here's why this is a problem. The bigger an object is, the rarer it should be. This is basic statistics. In any population of rocks floating through space, small rocks vastly outnumber big rocks. It's like going to a beach and counting pebbles versus boulders. There are millions of pebbles for every boulder. So when you're talking about interstellar objects, things rare enough that we've only ever detected 3 of them, the odds that one of those 3 would be this massive are incredibly low. Avi Loeb, the Harvard astrophysicist who's become the leading voice studying these objects, ran the numbers. The probability of detecting an interstellar object this large is less than 1 in a million compared to typical asteroid populations. Less than 1 in a million. Think about what that means. We've detected exactly 3 interstellar visitors, and one of them happens to be in the largest 0.0001% of possible sizes. That's like winning the lottery on your first ticket. Possible? Sure. Suspicious? Absolutely. But the size was just the beginning. Because when telescopes started analyzing the light coming off this thing, the results got even stranger. Part 3, the chemistry nightmare. This is where things go from unusual to actually disturbing. When you look at comets through a spectroscope, a tool that breaks light down into its component wavelengths, you can identify what chemicals are present. Every element and molecule produces a unique fingerprint in the light spectrum. It's like a barcode that tells you exactly what you're looking at. The Very Large Telescope in Chile pointed at 3 I divided by Atlas and ran a full spectroscopic analysis. And what they found shouldn't exist. Nickel. Lots of nickel. About 5 grams per second of nickel vapor streaming off the surface when the object was at 2.8 astronomical units from the sunday. Now, finding some nickel isn't weird. Nickel exists in space. But here's the problem. In nature, nickel and iron are married. They're formed together in supernova explosions. They travel together through space. They exist in the same ratios everywhere we look in the universe. You literally cannot have large amounts of nickel without iron. It's like finding a forest full of roots with no trees. It violates basic principles of how matter is distributed in the universe. But 3I divided by Atlas was emitting massive amounts of nickel with virtually no iron signature. The scientists couldn't believe it at first. They checked the instruments. They ran the analysis again. They had other observatories confirm. Same result every time. Pure nickel emission. No iron. Here's what makes this even more impossible. When you form a comet naturally, it's basically a dirty snowball. Frozen water, frozen gases, dust, and small amounts of various elements all mixed together. The proportions of those elements should roughly match what exists in the interstellar medium, the space between stars where the comet formed. And in that medium, nickel and iron exist together. Always. If you're seeing nickel, you should see iron at roughly 1/10 the amount. That's just how the universe works. But 3I divided by Atlas wasn't following those rules. The James Webb Space Telescope got involved and found something even more bizarre. The comet had a CO2 to H2O ratio of 7.6 to 1. That means for every one water molecule, there were more than 7 carbon dioxide molecules. That's not just unusual. That's 4.5 standard deviations above the trend for normal comets. In statistics, anything beyond 3 standard deviations is considered extremely rare. This was beyond that. To put it simply, 3I divided by Atlas doesn't have the chemical makeup of anything we've ever seen form naturally in space. Not close, not even in the ballpark. Later observations found that as the comet got closer to the sun and warmed up, iron started appearing in the spectrum. Scientists proposed an explanation for this. Maybe the object contained nickel tetracarbonyl and iron pentacarbonyl, industrial compounds that have different sublimation temperatures. The nickel compound would evaporate at lower temperatures, so you'd see it first. Then, as things heated up, the iron compound would start evaporating too. Okay, that explains the observations. But here's the new problem. Nickel tetracarbonyl and iron pentacarbonyl are industrial organometallic compounds. We make them in factories for specific chemical processes. They're not things you find naturally in space. So, the explanation for why 3I divided by Atlas has impossible chemistry is that it contains industrial chemicals that shouldn't exist in nature. That's not exactly comforting. Pod 4. The trajectory. Let me talk about the path this thing is taking through our solar system, because this might be the most statistically impossible part of the entire story. When something enters our solar system from interstellar space, it can come from literally any direction. Space is three-dimensional. There's no preferred plane, no highway that objects follow. Random interstellar visitors should come from random directions. But our solar system has a plane, the ecliptic plane. It's the flat disk where all the planets orbit. If you could look at the solar system from above, you'd see all the planets going around the sun in roughly the same flat circle. Now, if something comes in from a random direction in three-dimensional space, the odds that its path happens to line up with that flat planetary disk are very small. Most trajectories would cut across the plane at steep angles. 3I divided by Atlas is traveling within 5 degrees of the ecliptic plane. The probability of that happening by chance is 0.005%. That's 5,000ths of 1%. But it gets worse. The path 3I divided by Atlas is taking doesn't just align with the ecliptic plane. It passes close to multiple planets. On October 3rd, 2025, it passed within 0.19 astronomical units of Mars. That's about 18 million miles. In space terms, that's close, really close. Before that, it came within 0.65 astronomical units of Venus. And after Mars, It's going to pass within 0.36 astronomical units of Jupiter. This is what astronomers call a grand tour trajectory. It's the kind of path you'd design if you wanted to visit multiple planets with minimal energy expenditure. NASA has done this with probes. Voyager 2 did a grand tour of the outer planets, using gravity assist to hop from Jupiter to Saturn to Uranus to Neptune. That trajectory was carefully calculated by engineers to make those planetary encounters happen. The probability of a random interstellar object naturally following a grand tour path through our inner solar system is estimated at less than 0.005%. So we have a size that's 1 in a million. Chemistry, that's impossible. And a trajectory that has a 99.995% chance of not occurring randomly. At what point do the coincidences stop being coincidences? Part 5. The wow signal connection. Now, I need to tell you about something that connects to an event from 48 years ago. And this is where the story goes from weird to genuinely unsettling. On August 15th, 1977, a radio telescope in Ohio detected a strong narrowband radio signal. It lasted 72 seconds. It was so unusual that the astronomer reviewing the data printout wrote "wow" in the margin. That's why it's called the wow signal. The signal came from the direction of the constellation Sagittarius. It had all the characteristics of an artificial transmission. The frequency was right at the hydrogen line, 1,420 megahertz, which is considered a universal calling card for anyone trying to communicate across interstellar distances. Despite decades of searching, that signal has never repeated. We've never heard anything like it again. It remains one of the great mysteries of SETI, the search for extraterrestrial intelligence. Here's where it connects to 3I divided by Atlas. When astronomers traced back the trajectory of 3I divided by Atlas, working out where it came from and when, they found something disturbing. The object's inbound path aligns within 9 degrees of the direction the wow signal came from. 9 degrees. That's close. The probability of this alignment happening by random chance is approximately 0.6%. But here's where it gets really interesting. If 3I divided by Atlas transmitted the wow signal in 1977, it would have been about 600 astronomical units away from Earth at that time. That's way out past Pluto, deep in the outer solar system, but still within range. To produce a signal detectable on Earth from that distance would require a power source of somewhere between 0.5 and 2 gigawatts. That's the output of a nuclear reactor. Now think about the timing. If something wanted to announce its arrival, sending a signal while it's still far away makes sense. It gives the destination time to notice and prepare. And then 48 years later, the object arrives for a close approach to the inner planets. I'm not saying that's what happened. I'm saying the numbers work out in a way that's hard to ignore. And speaking of hard to ignore, let me tell you about what happened when this thing got close to Mars. Part 6. The Mars Images. October 3rd, 2025. 3I divided by Atlas makes its closest approach to Mars. 7 spacecraft from 4 different countries are in orbit around Mars or on its surface. This is humanity's best chance to get a close look at an interstellar object. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express both captured images from about 30 million kilometers away. The images showed what you'd expect: a fuzzy dot with a faint tail, a comet-like smudge against the background stars. But then NASA's Perseverance rover took some pictures. Perseverance is on the surface of Mars, driving around Jezero crater looking for signs of ancient microbial life. It has navigation cameras that occasionally look up at the sky for various reasons. checking weather, tracking dust levels, that sort of thing. On October 3rd, some of those images captured 3 I divided by Atlas passing overhead. And when amateur astronomers started analyzing the raw NASA data that was publicly posted, they found something that started an absolute firestorm of controversy. The images appeared to show a bright, cylindrical object streaking across the Martian sky. Not a fuzzy comet blur, not a smudged dot, a structured geometric shape, bright, moving fast, and distinctly cylindrical. The images went viral within hours. People were calling it everything from an alien mothership to a probe to visual proof that 3 I divided by Atlas wasn't natural at all. NASA stayed quiet. Avi Loeb analyzed the images and initially concluded they were likely motion blur artifacts from long exposure photography. If the camera's shutter stayed open for several seconds while the object moved across the frame, it could create a stretched, elongated appearance that might look structured. That explanation made sense. It was reasonable. It was exactly the kind of thing you'd expect from a scientist trying not to jump to conclusions. But then Loeb added something important to his analysis. He said if the navigation camera images were actually single snapshots with exposure times below 3.28 seconds, then the blur explanation wouldn't work. In that case, the object would be much closer to the camera and significantly smaller than the multi-kilometer comet we were expecting to see. In other words, if these were quick photos and not long exposures, then what was captured in those images was something separate from the main comet body. Something smaller, something closer, something moving independently. NASA has never released the exposure time data for those specific images. Think about that for a second. The exposure time is basic EXIF data. It's recorded automatically with every digital photo. It's not classified information. It's not sensitive. It's literally just a number that tells you how long the shutter was open. NASA has the data. They just haven't shared it. And right after these images started circulating, something even stranger happened. NASA stopped talking about 3 I divided by Atlas completely. Part 7, the blackout. This is the part that really bothers me, because this is where the pattern of information control becomes undeniable. For the first 3 months after 3 I divided by Atlas was discovered, NASA was all over it. Daily updates, press releases, encouraging amateur astronomers to observe and share data. They were promoting it as an exciting opportunity to study an interstellar visitor up close. Then October hit. The Mars close approach happened. Those Perseverance images started circulating, and NASA went silent. No more updates, no more press releases. The 3 I divided by Atlas page on NASA's website stopped being updated. Scientists who had been giving interviews stopped talking to the press. The timing coincided with a US government shutdown that started in early October, which meant a lot of federal agencies, including NASA, had reduced operations and furloughed staff. That's a convenient explanation for the silence. But here's the problem. The government shutdown didn't affect NASA's Mars Reconnaissance Orbiter, which has the HiRISE camera, the most powerful imaging system we have at Mars. HiRISE can resolve details as small as 1 meter across from orbit. It's the camera that could have provided crystal clear images of 3 I divided by Atlas during the Mars approach. HiRISE never took public images of 3 I divided by Atlas, or if it did, those images were never released. During a government shutdown, ongoing missions continue to operate. Satellites keep working. Data keeps being collected. What stops is the public communication and the processing of non-critical data for public release. So, HiRISE could have taken images. Those images would be sitting on a server somewhere. But they're not being released. Meanwhile, the European Space Agency also got quiet. Their Mars orbiters took those early images showing the fuzzy comet-like object. Then, nothing more. No further analysis. No additional high-resolution attempts. Just silence. China's space program stopped mentioning it. Russia's Roscosmos stopped mentioning it. When rival space agencies that normally compete for prestige and try to one-up each other all simultaneously reduce their public communication about the same object, that's not a coincidence. That's coordination. Something unified their response. Something made them all decide at the same time that less information was better than more information. And it's not just the space agencies. Social media platforms reportedly increased content moderation around 3 I divided by Atlas discussions. Content creators started reporting that videos about the object were being demonetized or shadow banned. Some creators began using coded language, calling it the visitor or the object, instead of 3 I divided by Atlas to try to avoid algorithmic suppression. Now, I can't verify all of those claims. Social media algorithms are opaque, and companies rarely explain their moderation decisions in detail. But enough people reported similar experiences that it became its own pattern. Let me be clear about what I'm saying here. I'm not claiming there's some grand conspiracy to hide the truth about aliens. I'm saying there's a documented pattern of reduced information flow about this specific object that coincided with the Mars close approach and the controversial images. And that pattern is weird. It's inconsistent with how space agencies normally operate. When something interesting happens in space, they usually can't shut up about it. That's how you maintain public interest and justify funding. So why the silence? What changed? Part 8. The forward jet. I need to tell you about one more anomaly, because this one directly contradicts our basic understanding of how comets work. When a comet gets close to the sun, the ice on its surface heats up and sublimates, turns directly from solid to gas. That gas carries dust particles with it, creating the comet's tail. And because of the way solar radiation and the solar wind work, that tail always points away from the sunday. Always. This is first week astronomy class stuff. The tail points away from the sun because the sun is pushing the gas and dust particles outward. 3 I divided by Atlas has a tail pointing away from the sun, just like you'd expect. But it also has something else. An anti-tail. A forward-pointing jet emerging from its leading edge. This violates the standard model of cometary outgassing. If the sun's heat is causing the sublimation, and the sun's radiation and wind are pushing the material away, then nothing should be coming out of the front of the comet in the direction it's traveling. Yet, observations clearly show a forward jet. Material is being emitted from the leading edge ahead of the comet's direction of travel. For this to happen, you need an energy source that operates independently of solar heating. Something internal to the object that's pushing material out the front. Now, there are some natural explanations. Maybe the object is rotating in a way that exposes different parts of its surface to the sun at different times, and the geometry just makes it look like a forward jet. Maybe there are volatile pockets beneath the surface that are venting in unusual directions. These are possible. But they're also requiring us to stack multiple unlikely explanations on top of each other to explain multiple anomalies. At some point, Occam's razor starts pointing in a different direction. Part 9. The resistance to change. Here's something that bothers professional astronomers even more than it bothers amateurs. When a comet outgasses, it creates a force. Gas jetting out of the surface pushes against the comet like a rocket engine. These are called non-gravitational forces, and they cause measurable changes in the comet's trajectory. We've observed this with every comet we've ever studied closely. As they heat up and outgas, their orbits change slightly. The trajectory shifts. You have to recalculate their path based on the ongoing outgassing activity. 3I divided by Atlas is actively outgassing. We can see it in the spectroscopic data. We can see the gases in the coma. We can measure the mass loss rate. All the evidence shows this thing is spewing material into space at a significant rate. But its trajectory hasn't changed. It's following its predicted hyperbolic path with what multiple astronomers have described as unusual precision. There's no measurable trajectory perturbation from the outgassing. For a natural comet, this doesn't make sense. The outgassing should be affecting the path. The forces involved aren't huge, but they're detectable. We have the instruments to measure these tiny changes, but we're not seeing them. There are two possible explanations. Either the nucleus is so dense that the outgassing forces are negligible compared to the object's mass, which would make it unlike any comet we've ever seen, or something is compensating for the outgassing forces. Something is maintaining the trajectory. If you wanted to be provocative, you might call that active trajectory correction. You might call that navigation. I'm not saying that's what's happening. I'm saying the observations are consistent with that interpretation. Part 10. The political response. What's happening behind the scenes in government is harder to verify, but there are some documented facts. Representative Anna Paulina Luna, a member of Congress, reportedly contacted Avi Loeb directly about the Perseverance images. She's not on any space-related committees. She's not a scientist, but she reached out specifically about this. That suggests the images got attention at levels beyond just internet conspiracy forums. Actual elected officials were asking questions. Multiple sources reported that military satellites were repositioned to maintain surveillance of 3I divided by Atlas. I can't confirm this independently, but it's consistent with how the US Space Force would respond to an unknown object of interest. NORAD, the North American Aerospace Defense Command, allegedly increased its alert status in early October to levels not seen since the Cold War. Again, this is difficult to verify because NORAD doesn't publicly announce alert status changes. But if true, it indicates military concern that extends far beyond scientific curiosity. Why would the military care about a comet, even an interstellar comet, unless they have information that suggests it's not just a comet? The October 30th event, which brings us to the moment everything has been building toward. October 30th, 2025. Today, as I'm recording this, 3I divided by Atlas reaches perihelion, its closest approach to the Sun date. The object is currently positioned directly behind the Sun from Earth's perspective. For the next 2 months, we cannot observe it. The Sun's glare completely blocks our view. No telescope on Earth can see it. No space telescope pointing away from the Sun can see it. It's in a blind spot. A natural blind spot created by the orbital mechanics of the solar system, but a convenient blind spot nonetheless. This is what some researchers have started calling the event horizon. Not because it's literally an event horizon like around a black hole, but because it's a period when the object could potentially do anything and we wouldn't know. It could alter its trajectory. It could deploy something. It could break into pieces. It could accelerate or decelerate. And we wouldn't see any of it happening. For 2 months, 3I divided by Atlas exists in a state of observational limbo. Now, here's where the physics gets really interesting. If you wanted to use the Sun's gravity to change your trajectory, specifically, if you wanted to slow down and remain bound to the solar system instead of flying off into interstellar space, the most effective place to do that is at perihelion. It's called an Oberth maneuver. You fire your engines at the lowest point of your orbit when you're moving fastest and when the gravity well is deepest. The mathematics of orbital mechanics mean that you get more change in trajectory per unit of energy expended at perihelion than at any other point. If 3I divided by Atlas wanted to stay in our solar system, this is when it would do it. This is the perfect moment. And it's hidden from all of our observations by the sun itself. The timing is suspicious. The opportunity is perfect. And we're blind. Part 11. What comes next? In early December, 3I divided by Atlas will emerge from behind the Sunday Earth's telescopes. We'll be able to see it again. And we'll find out what happened during those 2 months of silence. There are 3 possible outcomes. Outcome 1. The object continues on its predicted hyperbolic trajectory, heads out of the inner solar system, and eventually leaves our solar system entirely on the path it was always going to take. In this case, it's probably just a very weird natural comet. All the anomalies were coincidences or unusual but natural phenomena we don't fully understand yet. It'll go down as one of the strangest objects we've ever observed, but ultimately natural. Outcome 2. The trajectory has changed. The object has slowed down or altered its path or done something that indicates it's not following ballistic physics. In this case, we're looking at something that has propulsion, something that can navigate, something artificial. And then humanity has to grapple with the confirmed existence of technology from another star system passing through our solar system. Outcome 3. We detect radio transmissions, or see structured objects in high-resolution images, or observe behavior that's undeniably technological. In this case, we skip the debate entirely and move straight to the reality that we're not alone, and something from somewhere else is here. What's most likely? Honestly, outcome 1 is still the most probable from a pure statistics perspective. The universe is big and weird, and sometimes very unlikely things happen naturally. But the accumulated anomalies make it hard to be confident in that assessment. Each individual strange thing could be explained away, but all of them together? 7 major anomalies, each with a less than 1% probability of occurring randomly, all present in the same object? The multiplication of probabilities means the combined likelihood of all these anomalies occurring together by chance is effectively 0, which means either we're witnessing something that's effectively impossible but happened anyway, or one of our assumptions is wrong. And the assumption that's most likely wrong is that 3I divided by Atlas is natural. Part 12. The Loeb scale. Avi Loeb has proposed something called the Loeb scale for assessing the technological potential of celestial objects. It's meant to work like the Richter scale for earthquakes, a standardized way to communicate how likely something is to be artificial. The scale runs from 0 to 5. 0 means definitely natural. 5 means confirmed artificial. In between is a gradient of increasing probability based on accumulated evidence. Loeb ranks 3I divided by Atlas at a minimum of level 2 on this scale. That means it has multiple anomalies that are difficult to explain with natural processes, and technological origin should be seriously considered as a hypothesis. This is not a fringe position from someone with no credentials. This is a Harvard astrophysicist with hundreds of published papers and decades of experience looking at this object and saying, this warrants serious investigation as a potentially artificial object. Not confirmation, not proof, but serious investigation without dismissal. And that's what makes the information blackout so frustrating. Because serious investigation requires transparency, data sharing, and open scientific debate. Instead, we're getting silence and suppression. The people with the best instruments to study this object are the ones saying the least about it. The agencies with the most data are the ones releasing the least information. That's backwards. That's the opposite of how science is supposed to work. Part 14. The Fermi Paradox. I want to connect this to a bigger question that's been haunting humanity for decades. The Fermi Paradox. Enrico Fermi asked the question in 1950. If the universe is so big and so old, and if life and intelligence are reasonably common, where is everyone? We should see evidence of alien civilizations everywhere. We should have detected their signals, found their artifacts, seen their megastructures, but we haven't. The universe appears empty. There are hundreds of proposed solutions to this paradox. Maybe intelligent life is rare. Maybe it destroys itself before becoming spacefaring. Maybe advanced civilizations hide themselves. Maybe they're here, but we can't recognize them. One solution is particularly relevant to 3I divided by Atlas. The probe hypothesis. If you're an advanced civilization wanting to explore the galaxy, you don't send living creatures on thousand-year journeys. You send probes, robotic scouts that can survive the trip, gather data, and either return or transmit their findings back. These probes could be small, they could be self-replicating, making copies of themselves at each star system to explore even more systems. They could be passive, just collecting data and watching. Or they could be active, making contact when appropriate. If this is how spacefaring civilizations operate, then the galaxy might be full of probes. And statistically, some of them should pass through our solar system eventually. In fact, a few scientists have calculated that if probes were common, we should detect around 1 per decade passing through. We've now detected 3 in 8 years, and the first one was probably detected only because it came unusually close to Earth, and we happened to be looking. How many others pass through undetected? If the probe hypothesis is correct, if that's the solution to the Fermi paradox, then 3I divided by Atlas isn't an anomaly. It's exactly what we should expect to find. And the reason we haven't found more is because we haven't been looking properly. Until recently, we didn't have automated sky surveys capable of detecting these objects. Atlas came online in 2015. Pan-STARRS started operations in 2010. These are the telescopes that found all 3 interstellar objects. Before these systems existed, an object could pass through our solar system, and we'd probably miss it entirely unless it happened to pass very close to Earth. So maybe they've been here all along. Maybe interstellar visitors are common. We just finally built the tools to see them. And if that's true, then 3I divided by Atlas being artificial isn't a crazy outlier hypothesis. It's the most obvious explanation for an object that doesn't behave like a natural comet. Part 15. The information management problem. Let's talk about the elephant in the room. Why would multiple governments and space agencies coordinate to suppress information about an interstellar object? There are really only a few possibilities. 1. They're not suppressing anything. The silence is coincidental, the result of budget issues and government shutdowns, and the natural ebb and flow of how news cycles work. This is the boring explanation. It's also the one that requires us to believe that multiple independent organizations all happen to reduce their communication about the same object at the same time for unrelated reasons. 2. They've determined it's definitely natural, but unusually so, and they're being cautious about communication to avoid public panic or misunderstanding. Maybe they have data we don't have access to that explains all the anomalies, and they're waiting to publish peer-reviewed papers before making any public statements. This is the conservative scientific explanation. It has some merit, but it doesn't explain why they'd hide data or refuse to release basic information like camera exposure times. 3. They've determined it's artificial, or at least that there's a significant probability it's artificial, and they're managing information while they figure out what to do about it. This is the conspiracy explanation. But calling it a conspiracy doesn't make it impossible. Governments manage sensitive information all the time. If space agencies detected something that suggested we're not alone, there would absolutely be a coordinated response to control how that information is released to the public. Think about it from their perspective. You're NASA or ESA or any space agency. You've just observed an object that has too many impossible characteristics. Your scientists are running the numbers and coming back with probabilities that suggest it's not natural. But you can't be certain. And if you announce, "We might have detected alien technology," and you're wrong, you've just permanently damaged your credibility and possibly caused social panic for no reason. So, what do? You stay quiet? You collect more data? You coordinate with other agencies to make sure everyone's seeing the same thing? You brief government officials? You run scenario after scenario. And you wait until you're absolutely certain before making any public statement. From an institutional risk management perspective, that's the rational choice. But from a transparency and public trust perspective, it's problematic. Because here's what happens when you go silent. When you stop releasing data that was previously public. When you refuse to answer basic questions about images that are already circulating online. You create an information vacuum. And people fill that vacuum with speculation. Some of it reasonable, some of it wild, but all of it unverified because the people with actual data aren't talking. This is how trust erodes. This is how conspiracy theories flourish. Not because people are irrational, but because the institutions they're supposed to trust are clearly hiding something and won't explain why. Part 16. The worst theory. So let's talk about the worst theory, the one that keeps gaining traction every time something new surfaces. The worst theory isn't that 3i divided by atlas might be artificial. That idea is startling, yes, but also thrilling. If it were true, it would mean proof of another technological intelligence, a discovery that would redefine humanity's understanding of life in the universe. That's not bad news. That's history in motion. The worst theory is something else entirely. It's the idea that information about 3i divided by atlas is being handled so cautiously across agencies, organizations, and borders that the public may never get the full picture. Not because of malice, but because of fear of misinterpretation, panic, or misuse. If that's the case, then we might be witnessing one of the most extraordinary scientific moments ever filtered, delayed, or softened before it reaches us. Not because the truth is dangerous, but because the people in charge believe we're not ready for it yet. That's what makes it the worst theory. Because if it's true, it challenges the trust between institutions and the public. It blurs the line between careful communication and controlled narrative. It turns curiosity into doubt, and doubt into distrust. And that erosion, that quiet, creeping uncertainty, is what corrodes collective belief. It's what turns honest mystery into fuel for speculation. Every unexplained delay, every withheld data set, every coordinated response across nations, they could all have simple explanations. But together, they create a pattern that feels intentional, even if it isn't. I'm not saying this theory is true. I'm saying it's emotionally consistent with what we're seeing, and that's what makes it unsettling. Part 17. The polarization mystery. Let me hit you with one more technical anomaly that doesn't get talked about enough. When light reflects off a surface, it can become polarized. This means the light waves start oscillating in a preferred direction rather than randomly. The amount and type of polarization tells you about the surface properties, whether it's smooth or rough, what it's made of, how the particles are arranged. Comets are expected to show positive polarization beyond a certain angle. This is because comet surfaces are typically covered in small particles of ice and dust that scatter light in predictable ways. We've measured dozens of comets, and they all follow this pattern. 3i dividido por Atlas shows deep negative polarization. Negative polarization typically indicates a smooth, possibly metallic surface. It's what you'd see reflecting off polished metal or certain types of manufactured materials. It's not what you expect from a dirty snowball flying through space. Now, there are natural materials that can produce negative polarization. Certain crystal structures, some types of ice formations under specific conditions. So this isn't impossible to explain naturally. But again, it's another thing on the pile. Another measurement that doesn't match what we expect from comets. Another anomaly requiring a special explanation. At a certain point, you have to ask, how many special explanations can we stack on top of each other before we admit that maybe the simplest explanation is that this isn't a comet at all? Part 18. The rotation period. Here's something that recently got updated. The rotation period of 3 I divided by Atlas. Earlier measurements suggested it was rotating once every 16 hours. That's a bit fast for something this large, but not impossible. Rotation periods for asteroids and comets vary widely, but more recent analysis suggests the rotation period might actually be 16.16 hours. That's very specific. And here's why that number is interesting. 16.16 hours is almost exactly 2/3 of a day. More specifically, it's almost exactly 16 hours and 10 minutes. Which is 2/3 of 24.25 hours, one solar day on Mars. Is this meaningful? Probably not. It's likely just a coincidence, and I'm pattern matching on nothing. Rotation periods don't need to correlate with planetary days, but given everything else about this object, even the weird coincidences start to feel significant. If you were designing a probe to study Mars and you wanted your rotation to sync with the Martian day for some reason, maybe to maximize observation time of specific areas, this would be close to the rotation period you'd choose. Again, probably nothing. But I'm mentioning it because it's another tiny detail that makes you go, huh, that's odd. Part 19, the statistical argument. Let me lay out the statistical case in simple terms. We have 7 major anomalies. Each one has a probability of occurring naturally that's less than 1%. Some are much less than 1%. Size, less than 0.0001% probability. Trajectory alignment with ecliptic, 0.005% probability. Grand tour path, 0.005% probability. Wow signal alignment, 0.6% probability. Chemistry, multiple standard deviations from normal, effectively less than 0.1% probability. Forward jet, difficult to quantify but inconsistent with standard cometry models. Trajectory stability despite outgassing, also difficult to quantify but unusual. When you multiply independent probabilities together, you get the combined probability of all of them occurring simultaneously. And that number becomes vanishingly small. Even if we're generous and say each anomaly has a 1% chance of occurring naturally, which is being very generous for most of these, the probability of all 7 occurring in the same object is 0.01 to the 7th power. That's 0.000000000000001%. 1 in 100 trillion. Those are not good odds. Now, probability isn't proof. Just because something is unlikely doesn't mean it can't happen. Someone wins the lottery every week despite terrible odds. Unlikely things happen all the time. But when you're doing science, you're supposed to follow the evidence toward the most likely explanation. And the most likely explanation for an object with 7 statistically independent anomalies, each of which is individually improbable, is that there's a common cause making them not independent. What common cause would connect all these anomalies? What single factor would explain the size, the chemistry, the trajectory, the stability, and the polarization all at once? Design would do it. If the object was engineered for a purpose, all of these anomalies stop being random coincidences and become features. The trajectory makes sense if it was planned. The chemistry makes sense if materials were chosen for specific properties. The size makes sense if you need a certain amount of equipment or fuel. The stability makes sense if you have navigation. I'm not saying that's definitely what's happening. I'm saying the statistics point in that direction more strongly than they point toward random natural object that happens to be weird in 7 different ways. Part 20. The Drake equation connection. The Drake equation is a formula created by astronomer Frank Drake to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It multiplies together factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and so on. The equation is more of a thought experiment than an actual calculation because we don't know most of the values. But it helps frame the question of how common intelligent life might be. One of the terms in the equation is L, the length of time that a civilization releases detectable signals into space. This is important because if civilizations only broadcast for a short period before either dying out or moving to communication methods we can't detect, then the galaxy might have had millions of civilizations but very few active at any given time. The 3i divided by Atlas situation is relevant to this because it suggests a different approach to the question. Instead of asking, how many civilizations are broadcasting signals right now, we should maybe ask, how many civilizations have sent physical probes that are still active? A probe doesn't need to be maintained. It doesn't require an active civilization on the other end. Once launched, it can operate independently for millions or billions of years. It's a much more durable form of presence than radio signals. If advanced civilizations tend to explore via probes rather than broadcasts, then the Drake equation might be underestimating how much evidence of intelligence is out there. Not because there are more civilizations, but because the evidence they leave behind persists much longer. 3i divided by Atlas, if artificial, would be exactly this kind of evidence. A probe from a civilization that might not even exist anymore, still carrying out its mission billions of years after being launched. That's both amazing and sad to think about. The first evidence of extraterrestrial intelligence might be a ghost. A messenger from a civilization long dead, still wandering the galaxy on autopilot. Part 21. The implications of confirmation. Let's run a thought experiment. Imagine that, when 3i divided by Atlas comes back into view later this year, something extraordinary happens. Maybe it emits an unusual signal. Maybe its path shifts in a way that defies every known natural explanation. Or maybe new images reveal patterns or shapes that seem designed. What would happen next? First would come verification. Observatories around the world would compare data, double-check results, and test every possibility. Scientists would go line by line through the readings, searching for any ordinary explanation. That process could take days, maybe weeks. And while that unfolds, the world would start to whisper hints, rumors, fragments of data. The story would begin to take on a life of its own long before anyone made an official statement. Eventually, agencies and institutions would speak, carefully, cautiously. Something like, "We've observed unusual characteristics from the interstellar object and are continuing analysis." Enough to confirm that something remarkable is happening, but not enough to define it. Markets would react. Technology companies, research firms, even space-related ventures, all would feel the ripple effects of uncertainty and wonder. Faith communities would reflect. Some might see this as proof that life, in some form, reaches beyond Earth. Others might focus on what such a discovery says about purpose, creation, and the vastness of existence. Leaders around the world would meet. Conversations would begin about communication, ethics, and unity about how humanity should respond if we truly weren't alone. Social media would ignite. Excitement, fear, disbelief, hope all at once. Some would celebrate a new chapter for humankind. Others would question everything they thought they knew. And through all the noise, the scientists would keep working. Every telescope, every receiver, every sensor turned toward 3I divided by Atlas, trying to capture every bit of information before it slips back into the dark. Because even if confirmation came, even if it was truly artificial, it would answer only one question: are we alone? And in answering that, it would open 1,000 more. Part 22. The implications of non-confirmation. Now, let's imagine the opposite scenario. December comes, 3I divided by Atlas emerges from behind the sun, and it's following exactly the trajectory we predicted. No transmissions, no course changes. Just a comet doing comet things? Would that settle the debate? Not really. The anomalies would still exist. The chemistry would still be wrong. The trajectory would still be statistically improbable. The size would still be unusual. All the weird things that made us suspicious in the first place would still need explaining. Skeptics would point to the continued hyperbolic trajectory as proof that it was natural all along. If it was a probe, why didn't it stop? Why didn't it do anything obviously artificial during the perihelion passage when it would have had the best opportunity? But that argument assumes we'd recognize artificial behavior if we saw it. Maybe the probe did exactly what it was designed to do, and we just don't understand the purpose. Maybe it transmitted data in a direction we weren't looking. Maybe it deployed something we didn't detect. Maybe observing is all it was meant to do, and everything it needed to accomplish happened during the brief period it was in the inner solar system. Or maybe, and this is important, maybe it's genuinely natural but represents a type of object or formation process we don't understand yet. The universe is full of things we haven't discovered. Maybe 3I divided by Atlas is our first glimpse of some exotic class of interstellar object that forms in unusual stellar environments. That would actually be exciting from a scientific perspective. It would mean there's new physics or chemistry to understand, new formation mechanisms to model, whole categories of objects we never predicted. But it would require some very specific conditions that we've never observed anywhere else in the universe to create something with 3I divided by Atlas's exact properties. It would be solving one mystery by creating another. The truth is, without a clear smoking gun, either obviously artificial behavior or a complete natural explanation that accounts for all the anomalies, we might never know for certain. 3I divided by Atlas could leave our solar system, and the debate could continue for decades. That's almost worse than either alternative. At least confirmation or clear natural explanation gives us closure. Perpetual uncertainty is maddening. Part 23. Why this matters to you. You might be wondering why you should care about any of this. It's a comet or probe or whatever, millions of miles away. It doesn't affect your daily life. Whether it's natural or artificial, you still have to go to work tomorrow, pay your bills, live your life. But I think this matters more than most people realize. If 3i divided by Atlas is natural, it's still teaching us that the universe is weirder and more diverse than we thought. It's showing us that our models of how comets form and behave are incomplete. That's valuable. That's how science progresses. But if it's artificial, the implications are profound in ways that would eventually touch everyone. It would mean we're not alone. Not in an abstract, maybe there's life on some exoplanet way, but in a concrete, something built by someone from somewhere else is here now way. That changes everything. It changes philosophy. Every religion and worldview would have to incorporate the reality of other intelligent beings into their framework. Some would adapt easily. Others would face serious theological challenges. It changes our sense of vulnerability. If someone can send probes here, they have technology beyond ours. They know we exist. We don't know who they are or where they are or what they want. That's a fundamentally different security situation than thinking we're alone. It changes our priorities as a species. Suddenly, the squabbles between nations seem smaller. The things we argue about, politics, borders, economic systems, all of that exists in a new context. We're not just humanity divided into countries. We're humanity as a single species that just learned it has neighbors in the cosmic neighborhood. It changes what we think is possible. If someone else figured out how to cross interstellar space, that means it can be done. It's not just theoretical physics. It's engineering. And if they can do it, maybe eventually we can too. Our descendants might actually explore other star systems. The future suddenly has more possibilities, and it changes what we think we know. Science would have to grapple with the fact that something this significant was here, observable, and we almost missed it because it didn't fit our expectations. That's a humbling reminder that our understanding of the universe is incomplete and possibly wrong in important ways. Even if 3i divided by Atlas turns out to be natural, the fact that we're having this conversation at all is significant. We're finally taking seriously the possibility that artifacts from other civilizations might pass through our solar system. We're paying attention. We're not dismissing anomalous observations just because they make us uncomfortable. That's progress. Part 24, the observer effect. There's an interesting psychological phenomenon happening with 3i divided by Atlas. The observer effect, but applied to scientific inquiry itself. The more attention this object gets, the more political the science becomes. Researchers know their observations and interpretations will be scrutinized not just by peers, but by the public. That creates pressure to be conservative, to not make claims that can't be absolutely defended. This is understandable. Scientists don't want to be wrong publicly. They especially don't want to be wrong about something as significant as potential extraterrestrial technology. The career consequences of crying wolf would be severe. But this conservatism can also bias the inquiry. If you're scared of being wrong in one direction, you might overcorrect in the other direction. You might dismiss evidence that should be taken seriously because the implications are too large. This is different from healthy skepticism. Healthy skepticism says, this claim requires strong evidence. Let's carefully examine it. Fear-based conservatism says, this claim is too extraordinary. Let's find any alternative explanation, even if it also requires unlikely assumptions. I think we're seeing some of that with 3i divided by Atlas. The backlash against Avi Loeb for even suggesting these objects might be artificial has made other scientists reluctant to engage with that hypothesis. Not because the evidence doesn't warrant consideration, but because they don't want to be associated with what's perceived as a fringe position. But fringe doesn't mean wrong. Plate tectonics was fringe. Continental drift was mocked. The idea that bacteria cause ulcers was dismissed as ridiculous for years. Science has a history of initially rejecting ideas that later turned out to be correct. The way to avoid this trap is radical transparency. Make all data public. Encourage multiple independent analyses. Welcome competing interpretations. Let the evidence speak for itself rather than having institutional gatekeepers decide what hypotheses are acceptable to consider. That's not happening with 3I divided by Atlas. And the lack of transparency is what's fueling speculation and distrust. Part 25. The Silence of Scientists. I want to address something that's bothered me throughout researching this topic. Where are the scientists? Not Avi Loeb. He's been vocal. But where are the hundreds of other astronomers and astrophysicists who have access to the data? Why aren't more of them publishing papers about 3I divided by Atlas? Why aren't there competing explanations being debated in journals and conferences? Part of it is probably timing. Science moves slowly. Papers take months to write, review, and publish. The object was only discovered in July. We're in October. That's not enough time for the normal scientific process to fully play out. But part of it feels like intentional silence. When I look at the publication record, there are a handful of papers about 3I divided by Atlas's basic parameters: its size, trajectory, chemical composition. Basic observational data. But there's very little interpretive work. Very little speculation about what it means. That's unusual. Normally when something interesting shows up in astronomy, you get a flurry of theory papers. People proposing different explanations, modeling various scenarios, arguing about interpretations. The Oumuamua literature exploded with competing hypotheses. But with 3I divided by Atlas, even though it's arguably more anomalous than Oumuamua, the literature is thin. Scientists are describing what they see, but not really grappling with what it means. Why? Maybe they're waiting for more data. Maybe they're being cautious. Maybe they're scared of being wrong. Or maybe some of them know something we don't. Maybe there's been informal coordination to limit speculation until there's certainty. Maybe funding agencies or institutions have quietly suggested that commenting publicly on 3I divided by Atlas's potential artificial nature isn't career smart right now. I don't know. I'm speculating. But the silence is noticeable, and it's concerning. Science depends on open debate. When that debate doesn't happen, when smart people who should be curious instead stay quiet, it suggests there are factors beyond pure scientific inquiry influencing behavior. Part 26. The Amateur Advantage. Here's something interesting. A lot of the most intriguing observations and analysis of 3I divided by Atlas has come from amateur astronomers, not professionals. The Perseverance rover images that showed the cylindrical object, those were spotted by amateurs analyzing publicly posted raw data. Some of the trajectory analysis showing the planetary tour alignments, done by amateur orbital mechanics enthusiasts. The connections to the WOW signal, popularized by bloggers and science communicators, not academic papers. There's a reason for this. Amateurs don't have careers to protect. They don't need to worry about getting tenure or securing their next grant. They can speculate freely without institutional consequences. This is both good and bad. Good because it means genuine observations and analysis aren't being suppressed just because they point toward uncomfortable conclusions. Bad because amateur analysis can also be wrong, and without peer review, it's harder to separate signal from noise. But in this case, The amateurs are forcing the conversation that professionals seem reluctant to have. They're asking the obvious questions. They're pointing out the anomalies that professional papers carefully avoid interpreting. There's a long history of important astronomical discoveries being made or advanced by amateurs. Comet discoveries, supernova observations, exoplanet transits. Amateurs have contributed meaningfully to all of these. Maybe 3I divided by Atlas will be another example. Maybe the truth about this object will ultimately come from crowdsourced analysis by people who aren't constrained by institutional politics. Or maybe the amateurs are seeing patterns that aren't there, driven by wishful thinking and confirmation bias. Without professional validation, it's hard to know. But the fact that we're relying on amateurs to push the conversation forward suggests that the normal scientific process isn't working properly for this object. And that's a problem. Part 27, the December observation plan. So, what actually happens in December when 3I divided by Atlas comes back into view? Multiple observatories have already reserved telescope time for early December. This includes both optical telescopes and radio telescopes. Everyone wants a piece of this observation. The first priority will be trajectory confirmation. Did the path change during the period it was behind the sun? Even a tiny change would be significant. They'll be measuring position extremely carefully and comparing to predictions. The second priority is spectroscopic analysis. Has the chemical composition changed? Is it still emitting nickel without iron, or has that ratio normalized? Are there any new emission lines that weren't present before? Third is looking for radio emissions. SETI instruments will be pointed at it. If it's artificial and if it's going to communicate, the period right after perihelion would make sense. That's when it's closest to the sun and has maximum power available if it's using solar energy. Fourth is high-resolution imaging. Multiple space telescopes and the best ground-based adaptive optics systems will try to resolve the object's shape and structure. If there's anything geometric about it, this is when we might see it. All of this data will be collected within the first few weeks of December, and then we wait to see if anyone publishes results. Actually, that's the interesting part. Will the results be public? Normally, yes. Telescope time at major observatories comes with expectations of data sharing. Observations become public after a proprietary period. But if the results show something extraordinary, there might be pressure to delay publication pending additional verification. So we might be in a situation where observations happen in December, people know what they show, but official announcements don't come until early 2026. And that gap between observation and announcement is where leaks happen, where rumors start, where the tension between transparency and caution becomes most visible. I'll be watching closely to see not just what's observed, but how quickly that information becomes public. Let me bring all of this together. 3I divided by Atlas is either the most unusual natural object ever observed, or it's something else entirely. 7 major anomalies, each statistically improbable, all present in the same interstellar visitor. Chemistry that violates our understanding of how matter forms in space. A trajectory that looks designed rather than random. Behavior that doesn't match cometary physics. The object is currently behind the sun in an observational blind spot at precisely the moment when it could potentially alter its trajectory most efficiently. It will emerge in December, and what we observe then will either deepen the mystery or potentially resolve it. But what's almost as interesting as the object itself is the response to it. The coordinated silence from space agencies. The reluctance of scientists to publicly grapple with its implications. The increased information control around discussions of it. The pattern of behavior suggests institutional concern that goes beyond normal scientific caution. The worst theory, that authorities have already determined this is artificial and are managing information to prevent panic, keeps getting supported by new evidence of information control. Each new gap in public data, each refusal to release basic information, each suspicious timing of communication blackouts makes that theory more plausible. We're living through potentially the most significant moment in human history, the first confirmed detection of extraterrestrial technology, and it's being kept quiet. Or we're living through an unprecedented scientific anomaly that will teach us new physics. Or we're seeing mass psychology and pattern recognition create a compelling narrative from random coincidences. I don't know which one is true. Nobody does for certain. But what I do know is that the truth about 3I divided by Atlas matters. It matters scientifically. It matters philosophically. It matters for how we see ourselves and our place in the universe. And whatever that truth turns out to be, we deserve to know it. Not filtered through institutional gatekeepers deciding what we can handle. Not hidden behind classification or bureaucratic delays. The full transparent truth with all the uncertainty and implications that come with it. In December, we'll get more data. Maybe we'll get answers. Maybe we'll get more questions. But either way, the story of 3I divided by Atlas has already changed how we think about interstellar objects and what might be out there waiting to be discovered. The third interstellar visitor taught us that the universe is stranger than we thought, that our models are incomplete, that we should be humble about how much we actually understand. And it taught us that sometimes the most important question isn't, what is that thing? It's, why aren't they telling us what they know about that thing? The worst theory grows with each new image, each new measurement, each new piece of information that raises more questions than it answers. And until we get full transparency and complete data, that theory will keep growing, because in the absence of official truth, people will construct their own truth from the pieces available. And right now, those pieces form a picture that's hard to ignore. 3I divided by Atlas is still out there, still moving, still mysterious. And we're all waiting to see what December brings. Subscribe for the December update when we finally see what happened.